Welcome to this explainer. Today we're talking about how to operationalize AI literacy. We aren't talking about a collection of buzzwords here. We're looking at a rigorous software engineering discipline. If you're a technology leader or an architect managing a complex, regulated environment, you already know the definition of AI literacy is shifting fundamentally. We're going to examine exactly what that means for your systems, and we'll introduce a structural approach called the Model Tower.
You see, AI literacy is no longer just some internal training initiative you can check off a list. It's an actual regulatory obligation. Article 4 of the EU AI Act, which is in force as of February 2025, specifically requires providers and deployers to ensure AI literacy in their staff. But here's the critical reframe we need to talk about. Roughly 90% of what regulators are actually asking for has absolutely nothing to do with AI models themselves.
What they're really asking for is proper software engineering. We're talking about ownership, lifecycle management, solid documentation, decisions with a recorded rationale, and governance backed by actual evidence. This is the true load-bearing structure of AI literacy. The problem most large organizations face right now is that tribal knowledge, static office documents, and corporate wikis simply can't carry this weight. They're a lossy substrate for engineering knowledge, and they just don't hold up under scrutiny.
And that leads us straight to the auditor's fundamental question. How do you know? A corporate wiki might tell you who last edited a page, sure, but it has no opinion about where the facts on that page actually came from. There's a massive, critical gap between static, tribal knowledge and a provable, data-driven reality that can actually satisfy an auditor or your internal compliance team.
That brings us to Section 1, Structural Failure Modes. Let's look at a few widespread enterprise patterns.
The first failure mode we see across the industry is untraceable code. Picture tens of thousands of lines of AI-generated code handed to a team by someone who has no official role on the project. In a regulated environment, this is essentially untraceable ghost code. It represents a severe regulatory risk. You simply can't satisfy traceability or ownership obligations when code just appears out of thin air without a documented chain of provenance.
The second failure mode revolves around how we make decisions. Contrast the standard consensus decision model with these strict new regulatory requirements. Think about most meetings. Decisions are made by debate, consensus, or maybe a boss override, and the losing alternatives are effectively erased from history. But Annex 4 of the EU AI Act requires technical documentation of alternatives and trade-offs. If an auditor asks a counterfactual question, you can only answer it if those discarded alternatives still exist as recorded data. The final widespread failure mode is architecture reduced to pictures talked through in meetings. While a nice diagram is helpful for a presentation, static pictures completely fail interpretability requirements because they leave no structural trace for an auditor or an AI agent for that matter to traverse. Just having pictures is essentially the null implementation of describing a system architecture. What we actually need is a structure where the diagram is a queryable view of data.
Which leads us to Section 2, the Nazdanika Model Tower.
The structural solution to these regulatory obligations is the Model Tower itself. Think of it as a stack of small, open-source eCore micromodels, where each floor adds exactly one concern. We're talking about floors for provenance, ownership, access, lifecycle, and cost. Because of how inheritance works, everything built on top automatically inherits all the concerns from the floors below. You define ownership once at the bottom, and every single system built above it carries that data automatically.
Let's walk through 3 specific floors to show you how this mechanics works in practice. First, the role floor treats ownership as data. This means separation of duties becomes a simple query, which is exactly what regulators mean when they ask for named accountable persons. Second, the decision floor keeps alternatives, criteria, and trade-offs as data. This perfectly matches the Annex 4 technical documentation requirements we discussed. Finally, we reach the rooftop agent stack, where AI agents are governed by construction.
Because the agent model sits at the very top of the tower, it inherits the governance, threat, and lifecycle floors beneath it. This means your risk tier, your human oversight modes, and your threat surface exist and are fully documented before the agent makes its very first execution call. You aren't trying to retrofit governance onto an AI system after the fact. The system is quite literally born governed.
Let's move to Section 3, Payoffs in the Enterprise Estate. How does this actually generate return on investment?
Consider the immediate payoff for a massive Maven dependency estate. A standard scanner output just gives you a flat, overwhelming list of vulnerabilities. But when you parse that estate into the tower, it becomes a fully governed graph. Transitive vulnerabilities can suddenly be prioritized by ownership, blast radius, and remediation cost, rather than requiring a team to manually re-triage a flat list. The vulnerability sweep simply becomes a targeted query with the actual owners attached.
The exact same logic applies to legacy systems. When a legacy TIBCO BusinessWorks estate is modeled down to the activity level using the tower, it yields actionable, estimable modernization plans. Things like dead process detection, complexity metrics, and migration costs per component become entirely visible. Because the register is tied to the code structure itself, it simply can't drift from the reality it describes.
And this brings us to a rather fascinating realization. A legacy TIBCO BusinessWorks process, with its activities and XPath transitions, is structurally an agentic system. It uses tools and control flow with guards. Therefore, the work of modeling and governing your legacy estate is actually the perfect rehearsal for governing AI agents. Modernizing the legacy work and managing the AI work required the exact same structural literacy.
To ground all of this in immediate reality, 29 of these micromodels are built and published today. They aren't theoretical concepts. Each one has its own generated documentation site, and they're available as Maven artifacts to be used right now. You can start mapping your enterprise estate into a governed structure today.
A precise note as we close this explainer. This regulatory analysis is an engineer's reading of systems requirements, looking for what must be true to satisfy them. It isn't legal advice. Some floors of the tower are still being refined, and that refinement happens in public on first use. To see the published models and the full story, visit nasdonica.com. The next time an auditor asks, "How do you know about your AI systems?" will you point them to a static wiki page, or will you query your architecture?